Okay guys, we continue. So now we start by looking at the concept of dot product and extending it to the concept of area of the parallelogram. So let's consider a parallelogram. That's on the right. So we have a parallelogram here. So as you can see here, we can define two vectors u and v emanating from one of the corners of the parallelogram. So if one vector u there, another vector v, and then we can define that angle there as theta. So if we draw a perpendicular line from that corner there to the vector u, so we can define some height h, which is if you use this, you have a right angle triangle. So if you use sine rule, so basically what you have would be the magnitude, the length of v times the sine of the angle theta. So that would be if you use the sine ratio. Okay, but then we know that area is equals to base times height. So what we see is that the base, of course, the base for this vector, for this parallelogram, is actually this the magnitude of the vector u multiplied by the height. The height is just given by the magnitude of v and times the sine of the angle theta. So then what we can see is that we know that we defined cross product u of two vectors u and v as u for times the magnitude of v times the sine of the angle between the two vectors multiplied by some unit vector n in that direction. So but then we know that the magnitude of a unit vector is 1, so we can even forget about that. So actually we are able to see that actually if we get the magnitude of u cross v, we get just that, because now the magnitude of n would be 1, because it's a unit vector. So given that our vector n is a unit vector, then the magnitude of u cross v, so the magnitude of u cross v, which gives us the area of the parallelogram. So the area of the parallelogram is just the magnitude of u cross v, and it's given by the magnitude of u multiplied by the magnitude of v multiplied by sine theta. So this is how we get the area of the parallelogram. Okay, so far I haven't yet introduced to you guys on how to compute vector product if we're given two vectors in component form, or in terms of the unit vectors I, j, and k. I haven't introduced that this far. Okay, so before I introduce that fact, I realized that probably I need to introduce you to the concept of getting the determinant of a 3 by 3 matrix. I know you know how to get the determinant of a 2 by 2 matrix from grade 12, but then I was thinking maybe you guys haven't yet been introduced to matrix algebra. Maybe it would be important for me first of all to start by introducing you to how to get the determinant of a 3 by 3 matrix. So just to review that, remember when we're given let's say we're given a matrix, it's a 2 by 2 matrix. So we're given matrix A. So let's say we have 1, 2, minus 1, 4, right? So if we're told to get the determinant of the matrix A, remember what you used to do, just multiply the diagonals, right? One time is 4, 1 time is 4, minus the other diagonal, right? Minus 1 times 2. So in this particular case we get 4, the negative will become a plus, so plus 2. So the determinant of this matrix is what? 6. So now the question is, what if now we have a 3 by 3 matrix? So let me get some matrix B, which is 3 by 3. So let me have 1, 2, 3, 0, 4, 5, negative 1, 2, 3. So we have the 3 by 3 matrix. So how do we get the determinant? Okay, the good news is that we can actually reduce the problem of finding the determinant of a 3 by 3 matrix to a problem of finding determinants of a 2 by 2 matrix. How do we do that? Okay, so I'm not going to go into the actual proof and how we perform this using the principle of cofactors and everything, but I'm just going to give you a general procedure of how to go about doing that. Okay, so we use the first row. So we use these coefficients of the first row. So these coefficients of the first row will act as our we'll use them as pivots. So the first one, the first pivot is 1. The other pivot is, so just leave enough space. The other pivot is 0. Then the next pivot is the -1, so we leave a space. So then usually the pivots, in terms of sign, they alternate. So we start with the first one, it will have a sign of plus. The next pivot will have a sign of a negative. The next pivot will have a sign of a plus. Okay, of course, a plus multiplied by negative, we still get that. Then these will be multiplied by the determinant of a 2 by 2 matrix, plus also this one also be multiplied by determinant of a. Remember, when we use straight lines, we mean we're taking the determinant. So we'll have some 2 by 2 matrix that we'll have to place in there. So how do we do that? So we start with 1 here as a pivot. So as 1 as a pivot, so you just cross that, and then you cross that, because so you row and column. So the numbers which remain, those will be your 2 by 2 matrix, which you put there: 4, 2, 3, 5. Then if we use 0 as a pivot, let me use a different color. Okay, let me use maybe blue. Okay, if we use 0 as a pivot, so that will be the row, and this will be the column. The numbers which remain is 2. 2 remains there, another 2 remains there. We have a 3 and a 3 there. Okay. Then if we're using -1 as a pivot, so we have these rows cancelled, so we remain with the 2, 4, 3, 5. So 2, 4, 3, 5. So basically, so this is how we now get. So now this will be this we now get just now get determinants of this, and then multiply them by the pivots. And the pivots, remember, they have signs which are always alternating, starting from plus, minus, plus, and we always use the top row as a pivot. But of course, if you understand the whole method of cofactors, you can know that actually you can use in a row and a column as a pivot. But for now, I don't want to confuse you guys. For now, let's just stick to using the first row. Okay. Okay. So then what we have here in the end? So now we have 1. So we have 4 times 3 is 12, minus 5 times 2, we get 10. Okay. Negative. So 0 multiplied by anything, that will just be a 0. I don't need to do anything there. Then positive times negative, it's a negative. Then 2 times 5, we get 10. 3 times that we get a 12 there. Okay. So there we have a 2 minus 0 minus. Okay, there we get negative what? Negative 2. So this would give us 2 plus 2 there. So we get a determinant of 4. So basically, guys, this is how you go about computing the determinant of 3 by 3 matrix. Okay, I'll see you in the next lecture. Well, I'm going to show you how to get the cross product of 2 vectors given in component form, or given in terms of linear combinations of the standard unit vectors. Okay, guys, perfect. See you.